I'm honored to speak with our wonderful guest, Professor Dr. Roald Hoffmann. Professor Hoffmann is a Polish-American theoretical chemist, a Holocaust survivor, and the winner of the Nobel Prize in 1981. He has also received the William Nichols Medal, the National Medal of Science, 4MRS, the NAS Prize in Chemical Sciences, the Priestley Medal, and the Lomonosov Gold Medal. He has also published plays and poetry. He is the Frank Rhodes Professor of Human Letter and Professor Emeritus at Cornell University in Ithaca, New York, and is also a polyglot. Professor, the magnitude of your achievements is so great that I propose that we start our conversation. Our viewers can take a look at the video description below, where I will provide a link to your website and Wikipedia biography.
Right. Just, Nicholas, like everyone else of your listeners, this Wikipedia is to be trusted just around the corner of your finger. That is, I don't make up my Wikipedia page, someone else does. And sometimes and so there becomes an interesting question. Whose responsibility is it to get the Wikipedia page right? Or what does right mean when it's a controversial issue? Anyway, yes, people can find out about me.
Dear Professor, you were born in Złotów. Until 1949, you lived in Poland where you survived the German occupation. How do you recall your childhood?
So actually, we left Poland at the very beginning of 1946, when I was almost 9 years old. And and we eventually came to the United States when I was 11 and a half. So just 2 and 3 years later. Um, I remember as much as any child of that age remembers, which is not much from the war, and in particular, or from the wartime. And the closer we get to the present, the more I remember. The It's hard for me to tell apart what my mother told me and what I remember, or what my uncles told me. But I have reconstructed a lot. Um, we also lived in Poland before we left in three different places, starting out from Złotów and near there with for some during the war in a village nearby, and then we moved into Przemysl, and then to Krakow in the beginning of 45. And most of 1945, I was in a very happy situation in Krakow. The reason I put it that way is the war was over. And let me explain it to you in another way. When we were in a refugee camp the following year somewhere, there were kids in that class in my class, there were kids from between ages 9 and 15, because people had not gone to school during the war. We were very happy to get back into a normal life. Everything had been destroyed, and a lot had been destructed. I remember some things from Poland from that period. Krakow was not bombed out the way Warsaw was at the end of World War II. And we lived in Krakow, and I went actually to a local Catholic school there in Krakow, and I had a great time in school. So I remember a few things.
Some people think that chemistry is a very difficult field of science, not to mention a school subject. Is it true? Can you fall in love with chemistry?
You can, but I didn't in the beginning. So This is something interesting. One thinks that a person is going to wind up doing what they fall in love with or what they find most interesting. But let me put it another way. When I went to my high school now we were already in New York City, and I went to this science-oriented high school, and it was a very good high school. The only advanced placements course I did not take was in chemistry. I took them in physics, in math, in English, in every other subject. Why was that? Because the high school teacher in the first course was not too exciting. That happens also. One has to live with it. I did not make my mind up about chemistry until about 3/4 of the way through my PhD degree in chemistry. Until then, I just didn't know exactly what I wanted to do, but I think I was headed toward physics more, or the physical side of things, but not entirely. And when I went to college at Columbia, I started out college as a pre-medical student. I was preparing the courses in order to apply to medical school, which meant a lot of chemistry courses and physics and biology too. But then the world opened up to me at Columbia in college, as it will to you and to your friends in the university, because one can take in all that knowledge that flows in. And it was wonderful. And one way I make a joke out of it, but it summarizes the story. The story of my college career, which is still ahead of you sometime in the future, is that I did have enough courage in college to tell my parents I didn't want to be a doctor, but I did not have enough courage to tell them that I wanted to be an art historian. Okay, now what's going on there is my parents had the best intentions. They wanted me to have a career. They wanted me to make a living. A doctor seemed like a very good way to do this. And it capitalized on my science. But I actually fell in love with the humanities and the arts. But I didn't have enough courage to leave them. But I've kept up my interest since then. Long answer, but I've taken it seriously.
It is very beautiful, Dr. Hoffmann. Professor, you have devoted your entire life to theoretical chemistry. What, in essence, is this exact field of science?
Yes, I can tell you a little bit more. So first of all, it's a borderline of chemistry with physics. And in theoretical chemistry, people try today to calculate things, but they also solve equations. They do other manipulations of algebraic and geometrical matter. But they are not working in theoretical chemistry in a laboratory. I have published a few hundred papers in theoretical chemistry, but I haven't done a laboratory project since high school, essentially, or since college when I had to do it in a course. So what we do is we start with using the laws of quantum mechanics, which govern the motion of electrons at the microscopic level. And we try to solve approximately a set of equations called Schrodinger's equation, which is very difficult to solve exactly. And you can only solve it approximately. And there's a lot of cleverness in what approximations you use and how you approach the answer. And so what we do is using computers, using essentially applied math to operate the computers, we solve some equations which tell us where the electrons are in molecules. And then I got to be especially good at using one such concept called molecular orbitals, which are where, it's just a housing assignment for electrons, but I use these molecular orbitals to be able to predict for a molecule what its geometry was. Was it twisted like this, or was it twisted like that? I was able to predict distances in the molecules and how they would change if you shined light on a molecule. And that's what theoretical chemistry is. It's a calculation based on the principles of physics of chemical reactions.
Wow, that is so fascinating. At the age of 25, you had a PhD degree. At the age of 27, you make a discovery for which you are nominated for the Nobel Prize, which you receive in 1981. At 31, you become a professor at Cornell University. The so-called Woodward-Hoffmann rules, for which you were awarded, revolutionized the knowledge of organic chemistry and were a breakthrough in the pharmaceutical industry. How did the Nobel Prize change your life?
Yes, I just want to, Nicholas, to push your thinking into a little bit other direction, and then I'll answer your question. That I did these things when I was young is important, but you are not asking the difficult question. How did I survive after I did those? Let me put it another way. You don't ask that question of Brady or of Mahomes, a quarterback in the NFL. When their muscles give out, they'll give up their work. But my muscles are in my head. And what I need to do is not just to make a living, that's boring. I need to be intellectually making discoveries after the Nobel Prize, okay? And I have published, I told you, a few hundred papers. I've published 650 scientific papers altogether. Each of them just 4, 5, 6 pages long, but I've published a lot of them. And those papers, about 150 were published before the Nobel Prize, and 500 were published after the Nobel Prize. And someone must have been interested in those 500. Oh, they were. It's because I did other good things. Okay, now, but you asked the question, how did I do these things when I was younger? It was just a natural thing to do. I wasn't thinking about a Nobel Prize. I was just thinking of trying to understand the chemical world. And I had a way of talking about it with these molecular orbitals. It's been great fun. Now I'm much older. I'm 85, but I still enjoy every moment, and I still do a little bit of scientific work. Right now, I'm working on a paper with somebody at UCLA, and we'll see how it goes.
Well, I wish you all the best, Dr. Hoffmann, in that paper. But I would like to ask, how did you manage to achieve so much success at such a young age?
Oh, I don't know. The answer is I worked hard. I had the right parents and the right teachers, and there was a lot of luck. And we must not forget that I was in America. So the opportunities were there. The opportunities that one wants to have everyone to have, but that immigrants to America, as probably your parents were, they probably know what I mean by the opportunities. For my parents, who were in their 30s and 40s when we came to America, they could never work at the level for which they were trained in Europe, but in Poland and elsewhere. Actually, they studied in Vienna, both of them. But for me, the world opened up. If I worked hard, I could go anywhere. And that's what opened up at that high school in New York City, what opened up at Columbia University, and all of those things. So it helps to start out with the right genes, but that's not going to get you necessarily anything unless you do some hard work and you also have some luck.
In addition to all these wonderful achievements, you are the author of several volumes of poems. Have these awards helped you as a poet?
There actually are two ways. So the answer briefly is no. But now let me expand a little on that. So you have to first get at the role of the poet or the equivalent, the artist, in American society. And I'm sorry to say it's not very high. Not because anyone dislikes poets, it's just they're not willing to pay them. It's as simple as that. And if they teach something, maybe they'll hire them as a professor at the university or something, or an English teacher. But the heroic figures of our imagination, shaped by advertising and by everything else in the video culture that we are at, the heroic figures are not poets and artists. They are, unfortunately, rich people, entrepreneurs, people like that. So certainly that's the first thing. The second thing is it was never very different. It was that way 200 years ago in Poland, and it was that way 100 years ago in the United States. What I mean is that poets were never valued by their society. And certainly no one paid them to do what they want. They did what they did on the side of another job of some sort that they had. And I think that has kept on. So being a scientist and winning these awards realistically did not help me. I'm competing with other poets with getting my poetry published in journals or magazines that publish poetry, or in getting my books published. I work very hard at this business side of the poetry trade. And I do much better at that in science than I do in the poetry. And the fact that it's not only that there is some general, not prejudice, that there is some suspicion of the role of poets in our society, but it's also, it doesn't seem to contribute anything to tangible value in any way. The science, the poets have become therefore a little bit shy. They form their own society in a way. And so they understand well what I understand, and that is that our society values entrepreneurs and technologists and rich people and the people who make a new kind of sneaker, but that this is not they think also, some of the poets at least, that that world is the world of the scientist, but it isn't for the basic researcher. It's for the people who work for the manufacturers and for those. So there is some suspicion of scientists in the world of art and of poetry. And so being a scientist, in a sense, coming from the people whom society has helped and whom it encourages, or so people perceive it, that's seen not as a plus necessarily when I want, what do I want? I want to get my poem published so that it's seen by more than one person. I could put it on a website, yes, but I want to do more. I want it published in a book. I have a book here. It's called Soliton, and it's something I've written, and it's been published as a book. I want that for my poems. In this poem are 35 poems. In this book are 35 poems, but I would like everyone in the world to have it, not because I want anyone to be rich. I just would like to talk to people about it. But the question could be asked on another level, Nicholas, and that is there something about doing science that helps you write poetry? That helps me write poetry? That's a rather different question. So what I just said is doing the science does not help me get the poetry published. After I get it accepted for publication, the back copy of this book will have some little thing saying that I'm a Nobel laureate. Will it make you or your friends buy more copies of this book? I don't know. I don't think so, actually. So, but is there still something that about it? I think there is something about science. Science is a source of the imagination. It gets lost sometimes in highly technical words. That's especially true of chemistry. You've seen the names of chemicals, but you can write about emotions and feelings too, about chemicals. And I don't do this very often, but I do occasionally write poems with a theme that came to me from doing some science. So it has helped me, but it has helped me in another way. Poetry is a clear, direct way of expressing something. It has helped me, writing poetry has helped me write better scientific prose. It's not what I expected, but I learned that. The other thing is, it will take me a moment to explain. One of the problems science has is it seems to lack emotional content. And what poetry and songs do is they know how to endow words with emotional contact, with emotional context. And so I have learned a little bit. I have learned from my poetry how to write better scientific prose. That's not what I expected. It's been very nice.
Well, thank you for explaining so beautifully the essence of the poetry that you write. But I must ask, why is it that you write your poetry, Dr. Hoffmann? Are beautiful shapes and colors of molecules an inspiration to your writings?
Sometimes, but it often is from, I write the poetry because of it's the sound of the words and what they mean relative to each other. Um, and uh, and it is I write, or I write because there is an image that I want to convey. And so it's not so much the colors as such, it's an emotion or an image that I want to convey. But I know, and this I know in part from the science, is saying that vaguely is of no value whatsoever. To say that a flower is beautiful, a bird is beautiful, a molecule is beautiful, says nothing at all. Because the person who hears that, they have to put in a place their own bird, their own molecule. It's better if you work from specifics so that you give an example, you tell a story, a real story, and then, and this would be the advice for anyone starting out to write poetry, just tell some story. It doesn't have to be much. It's just a matter of going out with your dog for a walk. And the dog jumped at a piece of garbage that you didn't anticipate. There's a poem there. It's a very specific thing. That's how people learn to write poems. And sooner or later, you will connect up that dog jumping at that piece of garbage with something about garbage lying around the streets, with something about people not cleaning up their lawns and other things like that. So be very specific, I would advise, and you'll be well on the way to poetry. And nature is the best inspiration of all. Just going out for a walk in nature is wonderful.
Thank you for this wonderful advice, Dr. Hoffmann. Where do you get your ideas for projects that chemists later try to form into molecular networks of atoms?
Yes, so there I have no shortage of things. The reason is that we have this incredibly efficient communication system consisting of scientific journals, which in the old days used to be published in print, but today would appear on the web only and never in print. But every week I could count on there coming in hundreds of studies that have done by people around the world. The communication system is very open because no one in this group of people that I deal with is interested in hiding the discovery. And what they are more interested is in what they have learned, and also ultimately that they have learned it, so their reputation is at work in this in some way. Anyway, there are good journals and there are slightly less good journals and still slightly less good journals. But if I were to reach altogether, I would say that if I had a mailbox where I got these journal articles in on the internet today, I would get into that mailbox every week from the better journals in the world, let's say the top 50% of the journals. I have to make some judgment. I would get 1,500 articles every week. Okay, it's like getting 5 volumes of a book every week, and each of them reports something interesting. So it's all right. There's a lot of chemists working. I have trained many students, and they can do it. But anyway, there is no shortage of things to explain. Some of the cleverest ideas come when you don't try to explain something experimentally, but you try to think in another way. And that is, for instance, to think hey, this is a property of this molecule. How can I change it? How can I make the color shift to the red? How can I make its color shift to the blue? Those little perturbations, changes are, and you can sometimes devise very clever things. And then you, if you're a theoretician, you do a calculation, you publish it, and then the experimentalists get those 1,500 articles next week or whenever, and it's a network. See, what I wanted to say, in you talked about networks of molecules. I wanted to tell you that this network is made possible by a network of chemists, thousands around the world, openly sharing what they find. And this is very interesting, how this works.
That is surely very interesting and most of all very impressive that chemists around the world can collaborate so well. But as a person fascinated by all changes, how would you react to the slow introduction of artificial intelligence into all aspects of our lives?
Well, I am very suspicious of artificial intelligence. It's certainly introduced into our lives, but I would like people to think a little bit about the difference between uh, understanding and simulation. It's possible, you've seen with the recent discussion about ChatGPT, it's possible to simulate a conversation with a computer, and it sounds like it's in normal English, but all it's doing is gathering phrases for a specific purpose that's been used thousands of times by other people. It has a massive database it processes. The computer that translates Polish into English very well, and you maybe tried this, will there is you would laugh if someone said that computer knows Polish. The computer knows where to look in order to associate a certain word with a certain meaning. And so in the same way, we must not attribute intelligence where it's lacking. Let me give you an example in another way. Right now, and I'm giving you a real life example. Right now, there are Russians firing at Ukrainian artillery positions. Maybe you've looked sometime at how they measure the distance. They fire these over a distance of 5 kilometers or so. Now, here is one way to get a good sighting system. All you can vary, not all you can vary, but what you vary is the angle that you point the gun up. And then you could also vary the velocity of the gun and other things. So one way to do this is to fire that gun 100,000 times and figure out what it does. It is when you fire it at that angle, you'll see that it goes furthest when it's fired. It turns out not at 45 degrees, which one thinks it is. But it's actually a little high. And the reason it'll go, you want it to go along the ground because that's where the missile hits. But unless you're in an ideal world where it is just the force of gravity on a projectile pulling it down, it would be 45 degrees. But in the real world, the air has some viscosity and some friction, some resistance to the missile. So when the missile goes up, when it goes down, it hits the air. You can do this empirically. You can find a computer that in a fraction of a second can tell you where to point it, where to get that range that you want of 3.65 kilometers from where you are. that computer doesn't understand it. It knows how to compute it. So where does the understanding come? The understanding comes from Newton's laws of motion, what it is that influences, and then seeing that it's not just the angle, which is one thing, but it's also the viscosity of the air. And it's also the temperature, which affects the viscosity of the air. So all of these things can be reasoned out. But if you live in a world where you don't reason out anything at all, but you calculate everything on the fly, you will never understand. So this is why one has to be suspicious about the claims of automatic intelligence. It does not, I'm very suspicious of it.
Well, Dr. Hoffman, you give the impression of a very warm, kind, and at the same time happy man. Do you have any goals that you would like to achieve in the near future?
Right now, I'm recovering from COVID. So I didn't count on this, even the last time that I talked to you, but we all count on it. What I mean is, it's become a part of our life. I have a very short-term aim. I want to be back to really full strength so that I can walk a few miles. I'm not there yet. And eventually I want to live consistently with my age and hope to find some more peace in the world. It's not going to be easy. It's a pleasure to talk to you.
Likewise, Dr. Hoffman, I have one last question. As a man who has achieved so much success in his life, what would you tell to young people, such as myself, who are searching for their life path?
I think keep your eyes open to anything and everything, especially what's different. So what I mean is you're going to go into high school next. And in high school, you will be forced to take course. You will need to take some courses in a certain sequence, chemistry, physics, math, all along, chemistry, physics, biology. You're not going to get a course in anthropology, in archaeology, in French literature. I told you that the world opened up to me through the courses in the humanities that I saw in college. I would urge everyone, not just you, young people, to keep your mind open to the world in all its richness. Now, in some sense, you're already headed in that direction through the Polish connection. That is, you are in that way more open to things than just a typical American kid would have. But let's talk to people in general. I think to young people, I would say, keep your mind open. And otherwise, just have some confidence in arbitrary choices that you make, which seem to steer you in one or another direction, but they are always retrievable. Don't be afraid. Just go on and try something else.
Thank you so much, Dr. Hoffman. I would like to thank you so much for the opportunity to have this conversation with you. And I would most of all like to wish you many more great achievements and plenty of phenomenal health so that you can achieve what you wish to achieve.
Yes. Thank you very much, Nicholas. And please give my regards to your parents too.
Thank you.